This conference will now be recorded.
Okay, let me just share what I did. There are two things that I wanted to. So I kept the link initial. There two. I kept the link initialization spec really simple. Can you see the text?
Yep, we do.
If you wouldn't mind reading it for a second, I'll give you my questions at the end. That's actually the questions are this part.
Do you want typo fixes, by the way, or?
Oh, tell me.
Just on the very top on TX phi ready asserted instead of asserter.
Where?
3.2.2.3.
Oh, here. Wait. Oh, sorry. Okay. Oh, well. Thank you for catching that. But this is the text I changed. All right, and then never mind.
Oh yeah, no, that could indeed be a legacy typo.
But yeah, it's legacy typo. But yes, please. As if So the part I want feedback on. I mean, I have this glorified must here, and except with the thing I'm confused about is we're really saying it must signal through an out of band mechanism. That's it. It's a sort of loosely defined must.
And Bobby, what was your concern over that word?
Well, in general, I kind of had the impression that when we use the word must, we must also have, pardon the pun, we also require great clarity on how the must can be implemented and realized. And here I'm sort of hand waving and say just signal through an out of band mechanism. That's my concern.
Gotcha. I mean, it seems like on the one hand, this is being clear and explicit that there's an out of band mechanism. The fact that it doesn't go and specify that mechanism doesn't seem problematic to this statement, to number 3.
Yeah, I agree. I think this seems quite clear.
Okay. The second one, then I wanted the thing. I still feel that, okay, this is my feeling, but I'm happy to leave it. For this part, the RX phi logs onto the TX clause and signals phi ready. I feel like we should send a pattern, and that pattern should be a part of the spec rather than being left out. It should be like 1010 or something. Like,
I think you can. I think it's okay to list possible patterns that phis must support. But again, the phi may or may like different phis may or may not choose to use they may or may not choose to use specific patterns to lock on to do that quote unquote training.
Okay, so
but if we're going to be interoperable, I wonder if we do need to have a specific
but there's different patterns that you would want for different kinds of training. So unless we're going to get into the whole training sequence and everything, which
no, it's just for this one, just for the lock, because this is the personalized activity.
As Eric was saying, like depending on what people are doing, there's different patterns you might want to use. So I think it's perfectly reasonable to just say every phi must support the following set of patterns to allow interoperability with with phis that do need that thing, and then it's going to be up to sort of the link the link controller and or sort of the integrator to decide based on the data sheets from the phis of the two sides, like which pattern do I actually use, and yeah, but I think it makes a lot of sense to specify what patterns need to be supported. But whether or not sort of a pattern is used and how it's used and so on and so forth, I think is an implementation dependent decision.
So one question I even have on all that is, and I'm agreeing with what you're saying, sort of, but I think specifying nothing is the right thing to do here. And that is, if there's a protocol that you're going to run over this, that protocol will have some kind of way that it brings up the phi, right? And so my question is the usage model here one where Bo establishes a link on its own with no protocol and then a protocol is run over it? Or is the protocol inherently part of Bo? In other words, if I'm going to run, just say PCI Express over Bo, is PCI Express running from the get-go, or is the usage model that Bo is brought up and then at some later time you start running PCI Express across it?
Right. Well, if I could take a stab, it seems like what we're saying right now is halfway in between, meaning that there is a link layer, or a link layer controller, part of the link layer, that is participating in this on the TX and RX side versus solely the PHY by itself. And then to this matter of test patterns, it would seem like since we're not specifying the link layer or the link controller, which is what would be the source, presumably, of any given test pattern, that we're not specifying all of that. So then why would we be specifying specific test patterns? Because, you need to have compatible link layers on both ends.
Right.
And
That's what I'm thinking.
so,
the link layer would be
Wait,
telling
wait.
you what patterns to run, right?
But Greg and John, the spirit in which the spec is written there is that a TX RX slice pair. This spec tells you how a TX RX slice pair works. Not the whole
right,
link, but at least a slice pair.
No, but
right. And
I
so
think
as far as test patterns, it would be the link controller that would send the test pattern through the transmit PHY, and then the receive link controller would be looking at that. Well, I'm sorry, the receive PHY would be looking at that. But go ahead.
Yeah, no, I was just gonna say, I think, John, I think you actually hit the nail on the head in terms of what the question really is, in the sense of if the intention is that VOW files sort of are able to bring themselves up at least to some quote unquote workable state, and then we can discuss what workable means, then I think that drives things in one particular direction. If the intent is that the files are sort of not necessarily able to bring themselves up, then I think that sort of pushes in a slightly different direction. So maybe that's the question that we should answer for ourselves. I think my intention was to allow both possibilities, because I can sort of see from an implementation standpoint there are cases where you'd be perfectly happy to have the PHY bring itself up, and there's other cases where you might want sort of the link controller involved in it. But yeah, I think that's really the question to answer, and then based on the answer to that question, that would probably modulate what needs to be specified and where.
Yeah, I like the idea of not precluding either approach, right? That seems like gives you the most flexibility.
Yep.
But from that point of view, I was sort of like a no pattern camp to start with, but what you said made sense.
To be honest, but
I think having some patterns to say like, yeah, if the way you want to bring up a link is to establish the link and then tunnel something over it, then maybe having the PHY come up by itself makes sense. And I guess the patterns, though, that are sent should still come from a link layer above the PHY. Like, we should not be defining those in the PHY layer. We should make sure that the link layer in the link layer chapter puts in patterns that we feel are suitable for either, locking a CDR if that's required, or doing some equalization if that's required, or anything else, any other tasks that would be part of bringing the PHY up, right? But put those patterns in the PHY chapter, right? The PHY can never operate independent of the link layer.
Right. Yeah, I mean, it seems like all those things would be part of a link layer spec.
Yeah.
And most of those patterns and training would be associated with training between the TX and RX link layers. It seems like all we're talking about here is, some receive PHYs might want to be receiving a pattern just for the sake of locking onto the TX clock. Other PHYs may not need a pattern, but that's the only thing we're talking about here at this level.
When to start sending something, the PHY should never be operating without the knowledge of the link layer, right? The link layer tells the PHY, okay, start sending that pattern, whatever that pattern is. If you want it to be Nyquist or double Nyquist or LSR7 or whatever it is, the link layer says start sending this pattern now, right? the phi should never, ever, ever operate without the link layer's consent, right?
Well, that's fine, but if we don't define a pattern, then we are requiring every RX slice to work with any pattern at all.
Well, it's going to have to work with any pattern at all in the end, right?
Well,
We're talking about
trying to do clock training, to do clock alignment with any pattern at all.
Yeah. And once again, it's okay to do that, but the definition has to be in the link layer, and the link layer will say start sending that pattern, right?
Not at all. Not at all. If we want to, if we want to allow to force every RX to work with any pattern at all, then put it in the link layer. If we want to,
Even if you define specific patterns are in the link layer. If you look at any other spec, when it comes
Wait,
up,
I don't, John, I don't think we're debating that they need to come from the phi. We're in violent agreement on that. I think the key question is, do you want to specify a pattern or not?
I'm saying it's okay to specify a pattern, but that definition is in the link layer. The phi never decides to start sending the pattern. The link layer starts sending the pattern. The phi is dumb, right?
The phi can certainly require that I need this pattern in order to do
and that's
the
fine.
clock alignment.
And the link layer will decide when it starts sending it.
Well, yeah, that's right. It decides when, but it may be that we should be defining what pattern
We can tell the link layer they need to put it in their chapter is the point. That's going to be that pattern. We're not going to generate the pattern in the phi. The pattern is going to be generated in the link layer. Us defining it in the
phi can make a requirement on the link layer. It needs this.
Telling the link layer that we should do that is fine.
Well, no, because the phi is an independent standard, and we haven't tied the link layer to the phi. The link layer spec.
So I guess, Kent, maybe I think this might be a little bit of matter of semantics. I want to try and see if I can ask a question that maybe will help sort of bring sort of a conclusion, so to speak. Ken, I guess maybe I think the question sort of again comes back to, are you envisioning that the phi should be able to sort of, following the list of steps that Bappi has shown here, are you envisioning that sort of the phi should completely independently of intervention from the link controller, other than, sort of what's written here? Are you envisioning that the phi kind of like, brings itself up and sort of locks the clock and then says, based on a pattern, then comes back and tells the link layer, okay, hey, I'm ready? Or are you sort of okay with having the link controller sort of take additional steps in between to sort of, either set up the pattern or actually send the pattern or whatever it is?
Well, so we've already specified a link controller in this text, which is outside the phi, right?
Mm-hmm. Mm-hmm.
And this initialization is a set of requirements on what the link controller does, and I'm thinking that one additional part of this set of requirements on what the link controller does is it has to send this training pattern that any phi can use, any RX phi can use to do alignment. It's just part of the specification
for the link controller to do that. I'm just saying it's not it's not part of the phi spec. The phi doesn't even know the phi. You can do your design so that you're expecting that pattern, right? But the phi isn't going to generate that pattern, is all I was saying. The link layer.
I agree. It's not generating the pattern. It's just a requirement on the link layer.
Can I explain?
For the phi to transmit, the link layer will create the pattern and give it to the phi, put it on the bus, and the phi will transmit it out. The phi doesn't even know that it's the clock sync pattern. The phi should never even know that. Doesn't need to know that.
Well,
the designer of the phi benefits by knowing what that pattern is,
and that's fine.
Independent of what link layer is chosen. It's valuable for the phi designer to know this is the training pattern that I need to work with.
In a sense, could one express?
That the phi is going to come up sort of outside of a protocol, right? So it seems like that's what we're saying, right? Or at least I guess that's one of the things. Like Elad, you were saying that the we don't want to preclude either approach, right? So it could be that that never happens in the protocol. You're just running a protocol straight from the get-go. That protocol has, as part of its, a clock alignment section, right? And that would be fine too.
Well, isn't maybe the problem? Could one state the problem this way? We want to allow for receive phi slices that may or may not, require a pattern for the sake of locking onto the TX clock. And if we say nothing, then RX5 vendors, different vendors come along saying, hey, I require this pattern, I require that pattern. You have 20 different pattern requirements from 20 different vendors. And if the implication is that the transmit link controller needs to be capable of generating an arbitrary pattern, since the phi spec did not constrain what a receive phi could require, that's, I think, what's part of motivating this discussion. And so one answer would be that the phi spec, maybe constrains that, here's a set of patterns that the receive phi can depend on being supported by a link controller, and that receive phi can decide which one he wants to use, if any. Is that a reasonable way to state the problem?
I think so.
Yeah.
And so again, the point is, if we don't constrain the set of patterns that a receive phi could require one of, then that imposes this burden onto the link controller to be able to support any possible pattern.
So something like this. Basically, an RX slice will expect, I guess we're introducing a new word.
Well, an RX slice, may or can require a certain pattern to be sent as part of the TX clock training. I'm not using the exact words, but one of the following.
Can expect is important.
Yes.
Right. So if you think can expect, then you're precluding the case of the phi being brought up by the protocol. So I think, if we're going to support, say, that you could have either use model, you can say there are two use models for a bow. One in which the protocol brings up the phi, in which case clock alignment is outside the definition of the spec. In the second case, where the bow link is established independent of the protocol, one of the clock locking patterns are limited to the following set. Okay, something like that would be okay, right? So either we're going to preclude a case or not. If we're not, we have to explicitly not preclude it.
Wait, I don't understand something. Even if it's outside the scope and if it's a part of the link controller's function, as Ken says, the designer of the RX slice may need a specific pattern that if you leave it too broad. I guess I'm coming to, there's the choice of the pattern versus where it's generated. They're two different things. They're not the same thing. Even if it's outside the scope of the phi and the phi depends on a link controller to bring it up, you still have this problem of I need a pattern.
But right, but the point is the patterns that are used for that behavior may be defined as part of a link bring up, right? And not to be defined in the standard, right? Like if you're going to run something over top of bow that has clock alignment built into its initialization, you wouldn't want to do it twice because that would cause just additional latency and slow the bring up of the link.
But it's a phi property, right? I mean, in order to design my phi RX slice, I need to know. I don't see how we can get away without saying something, no matter who does the bring up.
Yeah.
No matter what the protocol on it, if I'm designing an RX slice, if Ken is right, which I'm assuming he is how do you How do you get away without saying something? You're not saying where the pattern comes from, but you're saying I need this pattern for my design to work.
You know, I don't believe there's a contradiction in the sense of I think the real question is just, you know, sort of the, like, in other words, there's a set of patterns that the link controller needs to know that it, you know, that it potentially would be able to produce. And so that phi designers would say, yeah, there's one of this, you know, I'm going to be able to use one of this set of patterns. And then I believe all the flexibility is retained and everything is sort of specified, you know, like the flexibility is retained, but things are not, you know, sort of infinitely unbounded in terms of which patterns the link controller or otherwise would need to be able to support.
Right.
Right.
So
And if there is a standard, if somebody wants to run, say, a protocol without doing that step, all I'm saying is there should be the ability for it to be completely independent, you know, maybe at the MAC layer instead of the link layer deciding how to bring up the phi, right? And hey, if your phi doesn't work in that application, it just doesn't work in that application, right? I think the problem is you're saying we want this to be really flexible, and somebody's saying like, I need this pattern to bring my phi up. If somebody says, I don't feel like sending that pattern, your phi just can't be used in that application, right? And I think that's going to be a rare instance, but the point is, I think, you know, anytime you say you have to do something, you're sort of putting a stake in the ground that's going to cause some other thing to be precluded, right? The question is, that's what I'm saying, if you have two use models, one is where the phi can sort of request or need a pattern. And what if you need a certain pattern and it's one of, you know, if we define 10 patterns, then your phi obviously has to be able to do clock alignment with all 10, because you can't just say as the receiver which of those 10 you're going to get, right?
Well, no, I don't think that's the intent. The intent is that the TX side must be able to transmit one of the specified 10 patterns. A receive phi can specify, here is the one that I require to be sent to me.
Specify it. There's no link.
No, but
I think by specifying just means in the
but there's
sense
a
of
data
somebody
sheet.
doing the integration would have to know, you know, look at the data sheets and say, okay, yeah, when I do bring up, I'm going to use this pattern.
exactly.
And you know what, so many times in this spec, I've said, oh, integrators are going to have some knowledge of the phi. I've always shot down. No, it just works. Now we're back to the integrators having to have skill in designing these links. I've always said, like, you're not going to be able to just go to Best Buy and buy these things and slap them together, right?
No, fair enough. That's a very fair point.
That was shot down earlier by everyone on this call saying, oh no, we want to make it so that it's completely mindless for the integrators. And I don't think that's the case. And I'm okay with that, but we just need to, but if that's the case, then, you know, maybe there's some register, you should define a register in the receiver. Okay, here's the 10 patterns. The receiver has a register that says which pattern it wants to bring up. And then through some higher layer, you know, whether it's I²C or whatever, reads that pattern and tells the other end of the transmitter what to send, right? Something like that could allow some flexibility, right? And not require custom, you know, RTL to be written as you know, integrate the phi, right? You would just say, hey, I've got a reader. It's a sort of a software thing at the top, and it decides how to set up the transmitter and bring the links up. I mean, the problem is either fully define how you're going to do this or don't define it at all. Don't do it halfway, because I don't think that solves the problem.
Well, no, but it seems like on the one hand, okay, yeah, maybe there's some unspecified way for, you know, the management software bringing up link to go find out what pattern the receive phi needs, and some way to go tell the transmit phi or link controller, oh, transmit this pattern at this point in time. Maybe we don't need to specify those details, but for the sake of someone designing an RX-Phi, and for the sake of someone designing a TX link controller, we need to say that, oh, okay, here's the 10 patterns that will be supported. An RX-Phi, if you need a pattern, you're going to have to live with one of these 10. You can choose which one. And the link controller, you're going to have to support being able to transmit any of these 10. And that seems useful.
You have to define the method for the transmitter, for the transmit link layer, to learn which of the patterns the receiver wants.
Wait, there's nothing dynamic about any of
having that
this.
in the data sheet.
It's static in the factory when the chip is designed. When the SoC is designed with all the component dying, you're going to choose, the link controller knows which pattern is going to send, and that's going to be it forever and forever, right?
So I've got IP. I'm not going to design an IP that sends 1 of 10 patterns, right? It's going to have a flexibility to do that. And the question is, do you harden that, or do you make it so that, hey, the way it works,
You don't have to harden it.
read
You
the
can
receive register every time, and you put out the pattern the receive register says, right?
Could there possibly be a hook in the sequence where the data layer could allow the PHY control over the transmitter to send whatever custom pattern it wants at a certain time if it wants to?
Well, I assume one of the patterns is no pattern at all, right?
Yeah, you could work on a, you could be data agnostic, or for PHYs that need a custom pattern, they could then have an opportunity to break into the transmit path and then inject it. And then
wait.
handshake that.
I'm missing.
Break the transmit path, right? The link
Hang
layer
on.
just does it, right? It's part of the. It's got to be part of the. That's what I'm saying. You don't break the link, right? You can't do that. You can't interject.
Wait, with
The
why
You
any of
could
this
if you had a handshake to do
hang
that.
on, one
Not the
second.
handshake all the way to the top. You can't be doing stuff.
None of this is dynamic. It's static in the factory. When you design the part, you know which pattern you're going to transmit, and that's it. When you come up, you know that the person who designs the part knows that the transmitter is transmitting a piece. You configure the TX. You configure the RX when you make it through some configuration bit. How you do it is an implementation detail. But the RX relies on the TX sending it a pattern that it can use to lock.
So the question now is, okay, so now let's think of a use model where the link's going up and down a lot, right? To save power. Do you need to go through this clock alignment each time, or do you just need to go through it once?
We're not supporting that mode in this first version of the spec. In the first version of the spec, we're simply saying there is no low power mode defined. In this mode, the only expectation from the RX is that the TX sends it a pattern which it can use to train. And there must be some configuration in each of the TX and RX which sort of says, okay, we're agreed on this pattern, but that configuration happens in the factory. It's
And then
not a
how long
dynamic
does it
thing.
send the pattern? How many cycles does it send the pattern?
For as long as the pattern is sent until the RX signals to the TX that the entire link is ready.
And how does it signal back?
Through the out of band. We're specifying this out of band mechanism.
Through out of band.
So
there's the implication. I'm sorry. There's the implication that there is, for example, a microcontroller that's actually talking to the two sides and doing this coordination and running through these 6 steps.
Yes.
And whether hardwired into that firmware for a given system, whether it's hardwired, here's the pattern the receive-PHY needs, or maybe the receive-PHY has a register that firmware can go read to find out. I think that would be equally allowable. But in any case, that firmware goes and somehow figures out here's the pattern the receive-PHY needs. Okay, let's go tell the TX link layer, transmit this pattern. Maybe that's specified through some register, again, not standardized here.
But Drake, none of this has to be dynamic. It's a design time. At design time, you sort of said pattern number 001 in some register in the TX, and you said pattern number, that might be pattern number 003 on the RX, and you're done. On all the TX, RX tells the TX is transmit a pattern.
So they have to have the same pattern. They have to agree on the pattern table, right?
But that's the whole point. You're specifying this at design time. You identify which out of the universe of training patterns you're going to choose. There's nothing dynamic about this.
No, I guess what I'm asking is, why does it have to be hardwired? Why can't we allow the freedom for an implementation to maybe that control firmware goes and however it discovers the required pattern for the receive-PHY, whether it's hardwired into the firmware or whether it goes and reads a PHY register. Why do we care?
Why am I biting off all this complexity in the spec? I just want to say use one of these patterns. How you use it is your problem.
No, it seems like we can allow the flexibility the sentence that you have there, all that would say is that the TX must be able to transmit any
I'm with
of the
you.
following patterns.
We are not specifying how it's done. We're just saying you need a pattern. Whether you make it
Yeah,
static, dynamic is up to you.
right. Yeah, so you must be able to transmit any of the following patterns. Not
But
that,
at least one or more. Well, that's why I said one or more, right? Must be able to transmit one or more.
no. The point is, if we're going to say, here's the allowed 5 patterns, to a receive 5 designer, he has to live with one of those 5. He can choose which one that he needs, but he
Yeah.
has to pick one of those. The TX side needs to be able to be told, oh, which one of those 5 should it send? If it's only able to send one of them, it may not be interoperable with a 5 that needs a different pattern. We're just specifying the set that if I can
You're
choose
saying
from,
it
and
should
that
be
So
any of. I see. You're saying the specifying any of the must be able to as a training sequence.
yeah, must be able to transmit any of the following patterns.
Training patterns for any of the okay.
And I would just say any of the following patterns. A set of patterns is, or any of the following patterns. Yeah.
Do I use the word training or not?
Maybe it's implied by saying this is for clock alignment, for RX clock alignment.
And then here this and then here I'm going to add a sentence and then say that the
It's
TX.
not the 5.
Say that again.
It's not the phi that's transmitting it. It's the phi is just carrying it.
Right.
That's right. I said here TX phi or LC.
Well, but it's not the phi that's originating the pattern.
Okay, the TX slice. We have to sum the or ATX. We need some word there.
No,
how about the LC?
TX link, the link layer.
So
Yeah,
I'm literally said
under
link
the
controller.
direction of the link controller.
Again, why do we care? We just saying that that needs to come out of the TX slice. Why are we sort of tying ourselves up in knots about where it comes from?
Well, it's a requirement on the link layer that it
Right.
be able to produce this pattern. It's not being generated on the phi. It is being generated in the link layer.
Yeah, why are we doing that?
Yeah, so that's why this whole discussion. The
I
phi
agree,
just
but
transmits.
I understand. I'm just saying, as long as the TX slice outputs this pattern, why do we care whether it's originated in the phi or comes from the link layer?
Well, no,
It's a
we're not
in the link layer.
because
we're not requiring.
The phi has to be done. I think is what you were saying, Eric, right? The phi
Yeah.
doesn't care where it gets the pattern from. It could be from the MAC, from the link. But the point is, the phi does not create the pattern. The phi is not a generator of data. The phi is simply a serializer of data. It takes a wider bus and it narrows it down and sends it across wires. That's its only job.
Yes.
That should be its only job. That's what I'm saying. We're doing all this. We're saying we're going to define that here, but really what we want to do is tell the link layer folks or a layer above us that they need to provide a pattern needs to be provided to us for this, and it has to be one of these patterns, whatever you want to do. But the phi doesn't store that pattern, doesn't generate that pattern, doesn't send that pattern itself. It just sends whatever pattern it's told to send.
So
And actually,
It does. If you
upstream of
ask
the
the phi of anything else,
right.
you're
And so, Bobby, what you wrote is, I think, kind of misleading.
Okay.
First of all, the TX slice as a phi must be able to transmit every possible pattern, or use any possible data pattern.
During clock alignment, right? During.
exactly. This puts nothing. This puts no requirement on the transmitter. Okay.
Right.
The receiver wanting a certain pattern, the transmitter, like you're saying, and what I said a long time ago was, the transmitter transmits every pattern, right? It's
Right.
going to transmit any pattern. So this doesn't add any requirement on the transmitter. Okay.
Right.
At some point,
And so, Bobby,
it's going to be able to transmit something, and it will do that. And that's all that, from a phi point of view. This has nothing to do with the transmitter. This has no impact on the
We're
transmitter.
coming up to 9:40. Let's settle on this text.
so Bobby, I think the quick fix is you say the TX link layer must be able to transmit
So
any
I
of the
have it
patterns.
here. The
No,
pattern
no,
is
no,
generated
no.
must be
It's not the
generated.
TX slice. That statement has no great meaning. Yeah, no, it's not the link controller. It's the link
It's not the
layer.
controller. That's something that tells the layer what link layer
Yeah,
what to
I'm
do.
staying away from the link layer term. There's one more thing. I think we want to say link controller because you don't want to necessarily imply the existence of a link layer, mandate the existence of a link layer.
Because the link controller is something that's directing the steps of the operation. It's not transmitting any data.
Right. I mean, in a generic sense, there will always be a link layer, however simple it may be. And the link controller is controlling the PHYs and talking to the other side and all these other things. That's a separate entity. So it really is the TX link layer. And you just have one, you can delete the highlighted sentence and just call that the TX link layer.
So how about I
Must
said
be
TX link logic?
Okay,
okay.
as long as it's clear that it's not part of the PHY.
And in
All right.
that case, it can be any pattern, not following patterns, right?
No, I thought the whole point of the discussion was that the RX was you're designing an RX that expected at least one of the set.
Yes.
So I can obviously, with the set starting at nothing, you can design an RX that can require many different things. I mean, we're not going to be the link layer compatibility is going to be something that's a lot more challenging and requires educated users, right?
But
Okay,
the question is, what patterns can a receive PHY depend on the transmitter side being able to send it? And we're saying, hey, well, we'll constrain the set of patterns that a receive PHY can choose from to require, instead of being able to require any possible pattern.
So I understand that's you can make a reasonable guess at that. I think that may contradict the intent of keeping this pretty open. I mean, there's going to have to be an educated person who makes sure that what they're using is a receiver on the other side. If it needs pattern, if it needs a clock pattern or a PRBS 11, that's what you're going to send it, right?
But
So
then
go ahead.
how do you then get interoperability between this PHY requires whatever God knows pattern, and then this other transmit link layer has no ability to generate that pattern?
Right. So when I mean, this isn't PCIe where they have to like plug and play. So the integration engineer is going to have to read the data sheet for the receiver.
I
Right.
get what Eric is saying.
Well, but so the integration engineer, if he has two chiplets that are already designed, he'd like to be able to put those together. And he's going to have to program the link controller, but he needs to not have incompatible training pattern requirements in the receiver and in what's hardwired into the link layer transmitter. So we need to constrain the set of required training patterns that the receiver needs to use.
So first of all, I didn't think it was hardwired into the transmitter. This might be semantic, but it is perhaps hardwired into the
TX link layer.
It doesn't need
into
to
the
be
TX link
hardwired.
layer.
It doesn't need to
Right.
be hardwired there, but somehow we need to know that it can provide that we can design an RX PHY to a specific pattern and know that it's going to be something we can get.
So the other way to think that this could work, Eric, and you kind of, I think we're pushing in this direction, is we don't define anything, and the receiver has a requirement, and so there's going to have to be some RTL written somewhere, right? It's not just like, hey, there's a bow link, and it just sends data back and forth, and that data has no meaning and goes nowhere, right? somewhere there is something intelligent above this requiring that bow link. And that intelligent layer will have to say, oh, when I start doing, I'm going to use vendor A's phi as part of this, when I turn on my link, I'm going to start transmitting this pattern because that's the pattern they want. And I know that from the data sheet. So I'll include the RTL to do that. So the receiver could just say, here's a pattern I want when I turn on. Here's my turn on sequence. You know, it could just be that.
So that seems
Like the link layer, right? The link layer often doesn't create patterns either, right? Usually it's the layer above. The link layer sometimes interprets what's happening in the pattern, but it doesn't really create the patterns, right? Like if you look at a protocol layer, the link layer isn't a generator of patterns either, right? It typically is does some intelligent interpretation of patterns, but it doesn't create the patterns. Because once again, the layer above it, at the top, you have to have the smart layer. The smartest layer is the highest up, and it should be in control of everything.
so
I
when you
think
talk
the
about
text here
writing
is good.
when you talk about writing RTL, then you're making an assumption that the receiver is known and that the transmit side is being
It should be known when you're putting this chip
that
together.
chip is being
Right?
created.
The system together, you know the receiver.
What if you have two chiplets which are already fabbed?
No, but I think, Ken, the expectation is for the kinds of chips we're doing. I'm comfortable leaving it like this for now and revisiting it as the market, as the use case is developed. We can default into a. If we learn more in developing the test chip, we can default into a specific pattern. But the expectation that there's some logic which is capable of transmitting
Yeah, good.
patterns it seems reasonable to me right now, especially given that we're saying there is an out-of-band management controller, et cetera, et cetera.
Well, you've got to at least constrain the size of the pattern for this to be sensible.
Right, because this is imposing a requirement on anyone developing a link layer IP. That IP needs to be able to generate, at the moment, any possible arbitrary pattern, which of
Okay.
course is impractical to support.
So then the following set of training, then we can at least have the following set of the following patterns are recommended as training patterns. How about we put in that text?
But are you effectively saying that the requirement on a TX link layer IP is that it only needs to support those patterns?
No, that's why I'm using the word recommended rather than must.
Well,
But right now you're saying the link layer must be able to transmit any possible pattern, because who knows what the RX side may require.
I
Right,
agree.
but if somebody requests a 2 to the 6th long pattern that's unique enough that you can't just count it easily, then maybe that is a phi that shouldn't work really well in the market, right?
Probably true, yes.
Right.
Yeah.
But
So
if we simply state at the beginning a link to the pattern that can be required, or all RX need to work with this pattern, then we solve it.
Yeah, constraining the length is a good way of doing it, right? As long as it's not insane, having a
Right.
certain length pattern generator is pretty straightforward.
I mean, in much more complicated standards, there is a reasonably small set that most people would put in, and it'd usually be a clock pattern, a PRBS, and they'd have a relatively short, like 320 bits or something, user programmable pattern, and that's pretty standard in a lot of products I've done. So, maybe constraining the size for the user programmable, is probably not a bad thing. Since this is not likely to have a lot of complex DFE, you probably don't need the richness of a long PRBS.
Well, can I ask, to Elad and others, that for a BOW receive phi, if it needs a data pattern to lock onto the TX clock, would it ever need anything more than just a fixed data pattern being sent over and over?
Generally, no. but obviously it depends on exactly what somebody implemented. But generally speaking, no, you should be able to send the same pattern repeated.
Right. So it seems like if we just say that a TX link layer must be able to transmit an arbitrary fixed data pattern, meaning it's the same 16-bit data pattern, maybe it's a 32-bit pattern over the two DDR, intervals, and that's the extent of the flexibility being imposed on the link layer to support.
So what's the wording?
If you had a register in the transmitter that was, say 32 bits wide, and that register gets written by the higher layer. So the higher layer, since we had to say there's a higher layer anyway to say when the links is locked, the receiver has the register, 32-bit register saying, here's what I want. The higher layer reads that register, writes it into the transmitter transmits that pattern, right? Like that would be a easy way. You don't have to worry about what the pattern is. The receiver can request whatever it wants. We limit the size by limiting the length. Then the transmitter design is done, right? It's like, hey, I've got this transmitter link layer knows I'm going to get a 32-bit pattern or a 64-bit pattern or whatever the length is, 128, I don't care. But just fix that rather than saying, oh, these couple of specific patterns, because no matter what you put in there, somebody's going to say, ooh, let's add this pattern and let's add this pattern at a later date. I think keeping it arbitrary is nice, but limiting the length seems like the way to get around, solve both problems. I like that.
But you
So
probably
what
want to
if,
add various PRBS patterns too.
because it would be needed for the receive side to lock onto the TX clock?
Possibly. I mean, there's typical, right?
Well, I mean, again, this is a low loss channel,
Yeah.
so I don't think I can come up with a scenario. I mean, the PRBSs are really useful for training equalization, for doing blind equalization, but in this case, I don't think anybody's going to be doing sophisticated blind equalization.
Yeah. And Eric, if you said the registers, it's 128 bits. That's even if you wanted to do something rich enough to train a receiver, that would be long enough to do it. Good enough for this kind of a link, I think.
For a link like this, that would probably be fine. I mean,
Yeah, exactly. Yeah.
And to be honest, I think everybody's built-in test is probably going to have something on that order.
Wouldn't you at least want a random pattern for test?
128 is random enough, right? Probably.
Yeah. The answer is those are very likely to exist for test anyways. So.
Right. I do. Yeah. The whole thing about random is that if you're a couple of times the channel propagation time,
right,
then it pretty much counts. So.
Exactly. You excite every mode of the channel, right?
Yeah. So I'm thinking. So I'd be reasonably happy with just specifying a maximum length and make it small enough so that people just put a user-defined register in.
Yeah.
Because to be blunt, we already have one. So.
Yeah. Yeah, and
what do you use?
Right. So that's a pretty long. Like, can we excite modes reflections longer than 7 UI away in this kind of a link?
What do you use?
Yeah, the only other thing I'd worry a little bit about is some people may be doing AC coupling or things like that. So I'd make it long enough to catch what they're doing. You're right. So far as the modes,
Yeah.
I think the longest thing in BOW listed is officially 50 millimeter. So, I would think a 128 is good enough to test just about everything.
So maybe
what do you
Bobby,
use?
I'm sorry, go ahead.
Eric, what do you use?
So, okay, every product we play with is different. So if I use my last 20 some years of history, I think 320 was the most common thing we used, but that was longer links than this. That was the last 10 years of PCIe. So for this, I think 128 is fine. If other people have a preference.
Greg gets to be the keeper of the text again. All right, the TX
Well,
link
I was just going to suggest, if we take the 128 number for now, the TX link layer must be able to repetitively transmit an arbitrary 128-bit data pattern. Must be able to repetitively transmit an arbitrary 128-bit data pattern.
All right.
But we should define a register and give it a register name, right? Hey, here's the register that you transmit at startup, right? And if it's all zeros, that means there is no pattern or something like that.
Although, then that'll be the only register this PHY standard specifies, and then at what address offset is it? How do you access it? Again, and all those questions.
Yeah.
And,
I say we declare victory here.
if I could shift back a second, where you say link logic, from a spec perspective, that's an undefined term. You're intentionally trying to be a little ambiguous, which is exactly what you can't do in the spec.
So
I think you need to say link layer.
Well, link layer or higher layer. What we're trying to get at.
Or higher layer.
No, but we do use the term core logic.
But link logic is not defined anywhere. I would agree with others.
I can replace the word link with core. Yeah, I really don't want to. I'm really hesitant to mandate the existence of a link layer.
Well,
okay, but that's not a major religious thing. We can always. I'm kind of uncomfortable with mandating the existence of a link layer. I would prefer core logic.
Yeah, I guess I have a hard time picturing any design that wouldn't have something you would call a link layer.
So I do want to have one important point. If we can, there is one last point, which I'm confident will resolve in 5 minutes, given how quickly we did this. We are eliminating in-band initialization. And I just want to point out that, when we originally did these 2 extra bits, they were meant to support in-band initialization with the aux and dbi bits. When you had these 2 bits, they could effectively function, especially if you had a symmetric link. You wouldn't need an out-of-band controller. You could essentially use these 2 in-band signals.
But the point is, though, those signals are on a per slice basis, whereas we're talking about training or bringing up a link of that may be multiple slices.
Yeah, but you could say that the link controller will assert all of them only when all of the, there's an easy way to specify that. I was thinking about there's an easy get around that. But basically,
I think yes, we are eliminating the in-band specification, and good riddance.
Yes.
Okay.
There's so much complication involved in that I love getting rid of it.
Okay.
Yeah, here as well.
And then that gets rid of this, Mark isn't here to defend it, but that gets rid of the simple A to D converter use cases, because you're saying they need the A to D converter has to have an external control thing to the main chip. I'm not recommending one way or the other. We're all comfortable with that.
Yes, although instead of requiring a couple of extra bumps on a slice, you're just requiring 2 bumps for an I2C link.
Okay. Well, we have the couple of extra bumps no matter what.
Right. No. So the point is, out of band doesn't cost you any extra. An I2C, 2 bumps, there you go.
Okay. Okay, so then it comes to the point when we mandate a control interface for the bow for the ODSA, but for now we're just sort of saying, waving a magic wand and saying out of band. Hey, Shahab, would you mind noting in the minutes, if you're taking minutes, that we're all deliberately choosing to disable, prevent, or not specifying in-band initialization, just so that if we come back to it, we know why we walked away from it.
Do you want to put the reason too, or just stating that we don't want to?
Are we just going to say Ken, Greg, and John don't, or whoever else spoke up, don't like it, or do we need something stronger?
And once again, you're not stopping the protocol layer from using in-band communication, right? We're just saying we're not defining it, right? We're not stopping it. In other words, if the protocol, whatever it is that you're running, says, I want to bring a link down, it could do that through the protocol if it wanted to, right? There's nothing that stops it from doing that.
Do we want to add that to the spec, or do we
We
just?
don't want to add that. I'm just saying, we just don't want to preclude it, right? That's all. And I think we're not, so I think we're good.
Oh, maybe okay. Maybe that right. Then we're not standardizing that. Like you cannot like.
Exactly. That's what I'm saying. You just want to we're trying to get flexibility out of this link so it can be used in as many applications as possible. And
Well,
the one thing I
yes
worry
and no,
about
right?
with if you say like, oh, you only communicate through this external link, that's super slow. So that precludes a link that wants to come up and down fast a lot to save power. And maybe this is not an application for this anyway, but allowing the protocol to do that, or at least not precluding the protocol from having the ability to do that seems, like an okay thing to do.
Okay, so I give you my spiel on why I see the two as being different. Because it's slow, the out of band, you can sort of kludge together disparate control mechanisms. This in-band bring up and control requires direct interoperation between the slices, and that's the only reason we would have to specify it if we wanted to support it, in my mind. Yeah, to me, there's a tighter interoperation between the slices if we want to use the DB and aux as control signals in a way that isn't for this path. So can someone give us a sentence for why we don't want in-band? I'm asking, not recommending. Can somebody do a sentence on why we don't in-band for the minutes so that we don't come back to this?
There's a huge amount of complication to specify in-band initialization, both at the level of how you specify the communication at the physical level, and then all the logic communication goes on top of that.
Okay, all right.
There's
Then we'll
wiring complexity to do something that's really at the link level.
All right.
We're specifying.
That doesn't seem right, Ken. I don't believe that's right. It's in-band is no more or no less. It requires one more thing, but it's going to be no more or no less than out of band in terms of control complexity.
I think it's much simpler than that. I think it's just it's none of the PHY's business.
It's none
right?
of
If somebody else wants to pack extra data on lines, like if somebody else wants to pack data on lines that the PHY is moving back and forth, that at a higher layer somebody else interprets, have at it, right? The PHY doesn't care.
Exactly.
Okay, fine. So Shab, that's our thing. It's not the PHY's. The PHY is simply a transmitter and should not have any control complexity associated with it.
Yeah, I got it.
So then we could in the future standardize something which kind of lets the controller use these two signals if it feels like it.
And again, it's the standardization be sort of above the PHY, right? The PHY sort of doesn't care.
Okay. Fair enough. All right. Okay, in that case, I am done. Okay, so I'm gonna. Hey, Ella, to your question, right? I think I've cleaned up sections 1 through 4 or 1 through 3, and 4 is just going to be left untouched. It's going to be the rump little, just the section of just the modes and nothing else. So if you could, I'm going to check this in if nobody has any objections. I think I've reviewed most of them.
I forked off of Ken's version that he had last touched maybe like 12 days ago or something.
So I was going to ask you if you wouldn't mind forking in. I'm going to check this in, and then if you wouldn't mind just redoing those sentences in this.
Okay, yeah, that shouldn't be too big of a deal.
And then that leaves me with just the end of the spec to clean up.
Okay,
Okay.
then I'm gonna push the rest of the basically items that we have from this week to the next week also. And I think that Mark had one thing about finding a CLA for releasing the spec. That was something that everybody should think about it, and maybe sooner or later we can talk about it as well.
Oh God,
Right.
yes.
There's actually one item, I mean, to the extent that some of the folks from the FI meeting want to trail off into the next one, there's one item that kind of touches on both sides, which is the one that I sent you guys out before this meeting, just related to the crosstalk spec, excuse me.
Hey,
So if you
Eric,
want, maybe we
I mean,
could
you'll have just
quickly,
one second.
yeah,
You'll have
yeah,
1 second. I'm going to do
of
two
course,
things. Give me 1 second.
of course.
This conference will now be recorded.
There you go. All yours.
Okay.
No problem, thank you. Shahab, are you also good if I bring that one up now, or?
Yeah, but I'm fine if you think it's okay for the
It's
basically.
sort of relevant for both, so yeah, maybe I'll
Yeah.
just quickly check with
I
folks.
know. I think Halil also had interest on it. I had interest on it. We really don't know where that graph comes from. I think it's come from me. But let's
Okay, well, yeah, maybe I'll do the setup just for everyone. So in the spec right now, there's I think it's figure. Let me look up what number it is. I think it's figure 13. Sorry, figure 17. There's a spec that sort of gives the power sum crosstalk limit line. There's sort of an equation, that sort of describes what the line is. So sort of the question, and then I'll explain the reason for the question.
Sorry,
The
do
question
you
was
want
if
to share
anyone.
your screen for those who don't have access to?
Oh yeah, sure. Actually, I guess I need to make me presenter then.
Bobby, you have to make.
Hang on. I'm going to make. Hey, can anybody able to take notes for this meeting? 1 second. Javi, can I volunteer you? May I?
Sure.
All right. I'm going to give you a document and just, thank you.
Okay, I think you guys can see. Oops. I think you guys can see my screen, right?
We do.
Okay, great. Yeah. So this is the spec as it exists in the in the draft format right now, and it just provides a crosstalk sort of limit line, power summed, and again, there's this equation over here that is in dB that sort of is describing what this curve really looks like. So the question was just if anyone sort of recalls or remembers sort of where the spec came from. And maybe sort of the related question is whether or not the intention is to maintain, this as being the spec. To be clear, I have no opposition to either answer. But the reason that I'm asking the question is that we did actually grab the models that came from, from this working group, from AlphaWave, I believe, were the ones that volunteered to put those channel models together. And when we evaluate the power sum crosstalk on those models, we see it actually violating the spec fairly significantly, particularly at the lower frequencies. So around 8 gig, it's like a little bit over a dB worse than this. At 1 gig, it's almost like 20 dB worse than this. Again, whether or not that is sort of reality or some modeling issue or this spec is kind of not the real spec, that's kind of the rationale for the original question.
One point of clarification. Sorry, Elad. First of all, this graphs. Last time we reviewed with Halil, I think we had the same question. What's the reference for it? The answer that we got was actually got provided by Ramin. We can double check with him where he get it or
Okay.
it's coming from his measurement. But one point of clarification: the model that you received, it's a silicon interposer based. Am I right?
No, I believe this is the. Actually, let me just shuffle some stuff around. Oh no, I don't want to do that. I'm trying to figure out how to stop sharing my screen for a second, just so I can go grab. I think it's here. No, that's weird. They changed around the whole like. Oh, there we go. I think it's there. Okay, yeah. Let me just bring up the slides from AlphaWave that they provided along with the model. and share that specifically. But as far as I know, this is a 110 micron organic, 727 stack up. Yeah, here we go. Yep, yeah, here. So this will be the useful.
Because the reason that I said, because if I remember Tony, when he presented, he said he's gonna provide the silicon interposer one. That's why I got confused.
Gotcha. Yeah, no. So this is the one that came from I think D and company.
Mm-hmm.
Yeah, so you can kind of see in the slide. This was provided along with the model. Get all these things out of the way. But yeah, it's 130 to 110 micron bump pitch. This is sort of the stack up that they gave along with it. It is the 727. You can kind of see. I'll actually go to the. So and these are sort of the crosstalk lines. Probably the easiest one to see how it sort of very badly violates is if you go all the way down here to like a gigahertz. If you sort of look at these numbers, the requirement is something like 42 dB power summed. You have individual terms that are obviously way above that. Again, whether or not like this is actually a problem or what we intended to do or etc. I can't judge because that depends on sort of like I don't obviously have the full context of where the spec came from. But if the spec is intended to be real, then we probably need to check with the channel model folks as to if maybe there was a sort of an issue in the modeling, or maybe there's sort of an adjustment that needs to be made to the sort of package design or etc.
I agree. This is a real issue.
Cool.
And
Okay,
all
so I
this,
guess
this presentation has been shared with this group, or
I think I sent you guys the email, which is this is sort of like hot off the press from our side too. So I'm happy to like send that around more broadly, or if you want to check with Ramin first on sort of where the spec came from, any and we're happy to help with any follow up.
thanks.
So Elad, how far apart are these chiplets from each other?
This I believe is 20 millimeter channel.
Okay, sorry, I missed that. Thank you.
Yeah, it's right over here. No, it's it's a dense slide. So yeah, this is modeling a 20 millimeter channel. As far as I recall, the intention with this model was to come up with something that was quote unquote reasonably worst case, so that folks could take that model and see, hey, if you work over this, you've got a very good chance of working kind of anywhere else. So yes, I think that's where this came from.
Okay, thanks.
Yep. So I guess Shahab, you'll reach out to Ramin.
Yeah, I can do that, because last time also we reached out to him and about the same graph. I can continue that discussion.
Sounds great.
Well,
And if you
also,
wouldn't mind, please do copy me as well.
Sure.
although, can we, I guess, just observe that, like, if you go to slide 6, what that would require, the BOW spec to have, would be, a curve that's, almost kind of like a shallow sloping line compared to what's in the spec currently. If you're able to switch back to it, is this exponential, which is a radically different crosstalk.
Yeah, no, we're the line from the model looks weird to us. It's not quite what we would have expected. Now, whether it's correct or not, different question, right? But it's definitely very different qualitatively versus the one that's in the spec.
Well,
sorry, when you say it's unexpected, go ahead.
Yeah, and I was going to ask the same thing. Elad, qualitatively, you would have expected this curve to look kind of like the one in the BOW spec?
It depends a little bit on kind of what the dominant coupling mechanism is. I can sort of come up with justifications for a few different behaviors, but a 20 dB per decade kind of slope would have been sort of the simplest model that would have made some sense. And this one is definitely not that. I don't know if Eric, you're still on the line, right?
Yeah, I'm here.
Yeah, you want to
comment?
Yeah,
I'm used to it. Yeah, it typically I'm used to seeing ones that curve down more like what the spec had, where it essentially mechanisms that are going to give you decent crosstalk at under a gig. That don't, something's weird here. So I'm not sure exactly what's represented. It's a little bit strange.
I don't know if it seems that strange to me. It's we can certainly take a look at the setup, but this is the bit error rate at 1 gigahertz something that is of high concern?
It's not so much that, it's more that basically crosstalk at almost any frequency can show up and hit your timing margin. And so the fact that it's at 1 gig, that like definitely means it's going to show up. And then yeah, it's really just an impact on your timing margin you get from the crosstalk, which is sort of the series of events that led us to look down this path.
Right. It's not really a matter of bit error rate at a particular speed. It's kind of the sum of everything that's within your receiver bandwidth, right? Because you integrate all of that up.
Yeah, so I mean, it could entirely be that this is all correct, and and this is what it's actually supposed to be for this particular package design, which is sort of why I phrased the question the way I did, in the sense of, if the spec is what we intend the spec to be, then that implies that this is not in spec. If the spec is something that that we're, from whatever reason, we believe is not the correct way to do it, then we should figure out the right thing is, and then we can check this design against that, whatever that spec actually is.
Sorry,
Do
Elon.
we
This
have a channel
presentation.
model? I'm sorry. Do we have an IBIS model that we'd be able to use for channel modeling of this interface to see if there, with a certain workload, to see if there is a significant bit error?
I mean, we've run a bunch of simulations just with the S parameters directly, running PRBS sequences and measuring eye diagrams and things like that. So I think we effectively can sort of answer a similar question, at least from a budgeting standpoint. Some of those things obviously depend on what you assume is kind of around the actual channel in terms of capacitance from ESD and sort of routing to the bumps and so on and so forth. But as I said, the intention here wasn't to say that this model is sort of good or bad. It was more just to check that we're sort of being consistent with whatever it is that we say the spec actually requires.
Right. Okay. Yeah. Good point.
Sorry, Elad. This presentation is shared with the ODSA community and the model or not?
I think, if I remember correctly, Javi, I think, forwarded me the link to the Google Drive that had
it's in a Google
kind of
Drive,
with all of these things. So my understanding is that it's intended to be shared with the community, but I don't know if it's been done directly or not. Javi, you want to comment further?
Yeah, let me take a look. I can post the Google Drive location in the chat.
Thank you.
Thanks, Javi. Okay, great.
Sorry, I have a question. So why do we need the tighter cluster spec at very low frequency? Low frequency, we will have more timing margin, right?
So again, just to be clear, this is the S parameter of the channel model. This doesn't say you're operating at 1 gig, right? So for example, if I'm operating at 16 gigabits per second, right, like everything down here shows up.
I mean for the spec, in the spec, why we need the 40, for example, 48 dB. Very low frequency in the spec.
Oh, so unfortunately, since I wasn't there for sort of the creation of it, I can only guess. But I believe the reason the spec was sort of, well, my guess is that the spec was sort of created from some assumption about what the physical mechanism of crosstalk really was, and then looking at the net impact that you would get from that physical mechanism, once you've sort of decided a certain level of coupling. So that's my guess as to how that was created. And again, just to be sort of clear, the fact that the crosstalk is a low frequency, again, specifically from a timing margin perspective, although even from voltage margin as well, that all just shows up directly as errors that the link has to live with.
Right. It's the power sum, I think, is referred to as technically the spec. Right. You're correct in that there's a number of curves that will give you the same power sum.
That's true.
So the reason I think they picked a curve like that is it's kind of typical what you're going to see on most channels. I mean, I think that's kind of textbooky.
Yeah, but I think this depending on the situation, also the channel length and everything will be considered. Also, for example, TX to TX coupling could be different requirement than TX to RX coupling, for example.
Correct. Yeah, I mean, the way the spec is written right now, it's sort of agnostic in the sense of it just says the power sum of all aggressors onto any victim must be, sort of within this power sum, sort of line. And by the way, again, to be clear, I'm not trying to cast judgment on goodness or correctness in either direction. It was more just, I opened the can of worms only to just see, if there were, if we were happy with the spec the way it was, great. Then we just, we need to adjust the channels. If the spec, on the other hand, is sort of out of date or whatever, happy, we can certainly adjust that as well. It was more just there is an inconsistency at the moment.
Yeah, I think that we need to modify spec. Yeah, the channel model you show me here is actually well explained in the real package substrate. It's actually correlated with our model as well. So,
So you were
yeah,
also seeing this sort of more, because this is about like a 10 dB per decade, approximate roll off.
yes,
That's also about what you're seeing.
yes, we do have the several different lengths of channel, and the crosstalk level and the shape is different for each channel lengths, for example. And this is more like correlate to longest side of channel length.
Yep.
And the data is very reasonable to me. So if the current spec cannot meet this kind of channel, then I think we need to modify. And also, I don't think that the spec does require that like 48 dB at low frequency. I don't think that is really required at that crosstalk level.
Yeah, no, fair enough. As I said, the intention wasn't sort of, cast goodness or badness. It was more just, we should all make sure we know where everything came from, and then, obviously make sure we're consistent and figure out what the, what the quote unquote right answer is.
Mm-hmm.
Great. Okay. Any other questions on this one, or?
I did want to ask to the person that was just talking a minute ago, the crosstalk, curves that you see for what you've done, is it worse than this or better than this by some amount? The point being is, if, for example, if the BOW spec was updated to reflect something like this, is what you see even a little worse and would not meet that updated spec?
Yeah, we see a little worse than this for the short channel link. But yeah, as I mentioned, it could be different. I mean, TX to TX crosstalk could be lower than the TX to RX crosstalk. So I think we need to specify the every situation.
I know. So by the way, this one is specifically fixed right now.
Yeah, but for example, TX to RX near-end crosstalk also important, right?
Oh, of course, yeah.
So we need to specify near-end crosstalk as well as fine crosstalk. For example, fine crosstalk TX to RX coupling is important. Fine crosstalk TX to RX, and near-end crosstalk also TX to RX crosstalk is more important.
Yeah, no, so as I said, the way the spec is written right now is it's a power sum, so it sort of doesn't care whether it's far end or near end. It's just, all aggressors. But if you guys are seeing things that are worse, I guess, if there's anything that you could sort of share, we'd be happy to share kind of results on bit error rates and things like that. But maybe more generally, yeah, it sounds like we will need to sort of dig up a little bit of history and then kind of decide collectively what the right requirements really
Yeah,
should
the
be.
actually 2 mm channel is much worse than this. So for example, you are saying this is about 20 mm channel, right?
Correct. This is 20 millimeters.
Yeah, it's actually we have similar crosstalk level with this one, but 2 mm channel near-end crosstalk power sum is anywhere to 13 to 15 dB level. Far crosstalk is the 20 dB at 8 gigahertz frequency.
Oh god. Okay. Yeah. That's substantially worse.
Yes. So it's depending on the channel and geometry, and also on pitch and everything, and the stack up.
Right.
Also, micro streamline could make that difference as well.
Yep.
Yeah. So we need to spec need to be considered all different cases.
Yep. Agreed.
And then I guess the one rippling issue here, right, is if the crosstalk's significantly higher than what was anticipated in the spec, then you have to worry about the impact on the error rates, right?
Yep.
That we're proposing for the spec.
Yes.
Yeah. No. Certainly.
That's how we got into this can of worms.
Yeah.
I mean, I guess the other thing I would point out is that that we if we're at those levels, we may also have to specifically provide in the spec for additional protection on the clock lines, because there's additional factors of 6 dB you can pick up there that could really get you into trouble. Okay, so I think the follow-up is, Shahab, you were going to check with Ramin on kind of where that one came from. Since this one does sort of branch between somewhat two groups, are we going to continue on this discussion kind of technically here in the test strip meeting, or sort of move this back to the PHI meeting, or try and do like the last half of the PHI meeting and the first half of the test strip, or what's the plan of action?
Well, I think we need to understand what's the impact on the bit error rate with these channels. That's going to be the primary metric. And if the bit error rate is too high, then we need to figure out, modify the design, such that it's not, we have different lengths, different stack up. Maybe we have different impacts. I think this here was all of the routes that are on the top layer, right?
Correct. This is the top layer route. That's correct. So this one is, so actually maybe I'll just walk through it quickly. This one is slightly more moderate from a sort of loss standpoint on the signal lines themselves, but more significant on crosstalk. There's also the layer 7 traces which are provided. Those are slightly worse from a sort of ISI standpoint, but noticeably better from a crosstalk.
Yeah. So that's right. So the lower layers, I guess B, C, and D will be much better on crosstalk. We'll have the most reflections on the fourth layer because it has the longest. You got to go tunnel down to more layers.
Exactly.
That makes sense.
Yep.
Yeah. So I think we got to determine. Again, boil it back to the bit error rate, and either we need to modify the design, which could be tricky. There's not too much. There's some things that can be done, but nothing too significant. Or you've got to change the spec. But I think,
no, exactly. I mean, a lot of these obviously are multidimensional in the sense of, there's kind of a budgeting exercise one can do to figure out kind of how good all the circuits need to be to operate with this. So yeah, so we're happy to sort of share some preliminary data on what kind of a set of assumptions are made on each side, and what that does based on differing assumptions about the crosstalk level.
Okay. Yeah, this could have an impact. If we need to reduce this crosstalk, I think the one, I guess the one knob that can be turned is to force this into having to be a microstrip. So that'll fix it, right? So that increases the package layer count. Yep. We'll need, but I think before we go down that path and go too conservative, I think we should just, we need someone to sign up to channel model this.
Yeah, no, that makes sense. And actually, I guess, Javi, I assumed you and others have sort of looked at the stack up, and this was kind of roughly a stack up that you guys all thought was a good, reasonable place to be at.
Yes, the stack up makes sense, and this was meant to be somewhat of a worst case on length.
Yep, makes sense.
Or can we have the ICR spec instead of just crosstalk and insertion loss? I mean the insertion loss to crosstalk ratio.
We can, although I suspect it won't be dramatically different in the sense of almost all the insertion losses are quite small. So, I think that'll make like a dB or two of quote unquote difference relative to kind of the power sum crosstalk at the moment. So I don't think there's anything wrong with it. It's just that I think it'll still mostly boil down to how much crosstalk are we saying we want to tolerate.
Right, that's true. But shorter channel, for example, it will have the lower insertion loss, but higher crosstalk. Longer channel, it will have the higher insertion loss, but lower crosstalk. So
right, no, totally agreed. But that's kind of what I'm saying is, if you look at sort of even this layer 7 one, which is the longer one, right, you're not even really hitting 3 dB insertion loss. So from the shortest to the longest, there's probably at most like a 3 dB difference there. Whereas the crosstalk levels, it sounds like you're seeing easily 10 plus dB types of differences. So that's what I was sort of saying. I think it's mostly still just going to come down to crosstalk.
Right. Yeah. So yeah, I'm just think about if we can have like ICR spec, like IEEE standard, that would be better to cover all different cases.
Yeah, no, I'm perfectly. I think that makes sense. Yeah. My personal opinion, obviously, right?
Sorry, I was typing some notes there. So Elad, just wanted to just verify, did you agree to share some channel model results on this?
Yeah, I mean, so what we can certainly do is, we definitely have relatively easy setups for just, running deterministic eye diagrams and, sort of showing kind of, what those look like. These are all relatively short, so, full statistical models, obviously one really needs to do for full thing, but for the purposes of kind of, these design exercises, the eye diagrams seem to be working pretty well. So we can certainly share those. Particularly if people do have other channel models they can share that they sort of have varying levels of crosstalk, just to sort of make our lives easier in putting everything together. That'd be great. But we're happy to share results on whatever we've got.
Has anyone else done channel models?
Yeah, we can share our channel model as well. Who might you send to?
If you wouldn't mind sending it to me, that'd be great. Or obviously, just share it with the the group. That's great
Okay.
too.
Yeah, I can send our channel model to you.
Awesome. Thank you so much.
Thank you.
Great. Okay. I think we've got a plan of action. So I don't know, Shahab, were you keeping the rest of the agenda, or?
I don't know,
No,
Bobby.
Shab, I don't want to. Per Shab volunteered for the Bo agenda, not for the test chip agenda. That's still like
Fair
a
enough.
floating work of art. Wait, let me pull up give me 1 second. Actually, I would love a keeper of the agenda for the test chip as well. There is one thing I did want to discuss for the test chip. We're beginning, the model we want to settle on is community funding, not just from the end users, but from the semiconductor vendors as well, if possible, and other companies in the workflow. So give me 1 second. I'll pull up the document. So to this end, give me 1 second. Here you go. Okay. So DJ is making DJ, you're online?
Yes, I'm online.
Okay. So it's hard to see under the surface, but please trust us when we say there's a whole bunch of progress going on, both with the end users and surprisingly more unexpectedly, not surprisingly, with the OCP as well. So it's some bonus. And I think it's time we're sort of trying to cast also a net and say whether we can also get more community funding so that we have 2 or 3 legs for funding this. And roughly,
so Bobby, I can add few quick points. So
yeah,
the idea here for all of us is, when everybody has a skin in the game, collectively we are stronger, right? If only few people have skin in the game, then the decisions are always askew. And that is the motivation behind this discussion which Bapi has launched right now. We want all of you to consider this proposal, think of ways to participate, because your company participating in this proposal is going to do 2 very important things. One, your company will have a signaling mechanism to the industry, which you can leverage for your own business wins by explaining how you guys are thought leaders, how you're driving the industry change, and this can provide you that signaling mechanism. That's number 1. Number 2, this actually allows you to also participate in any benefits which come out of this effort, access to data, access to information, which is, in itself a big win. Signaling is also a big a strategic win, but tactical win would be you will have access to things which others may not have if you are not participating, and you have skin in the game, so you also have ability to influence to the extent possible. So with that, I will go quiet. Bapi, back to you.
Yeah. So thanks, DJ. So anyway, the brief version of this is that I think we're looking at end users to come in this gold level. Is that fair, DJ? And what they're thinking is that the rest of the community can come in on the gold, silver, or bronze levels. The gives and the gets we're working on it, but I wanted to at least socialize the idea of broader participation in the funding. And there are 2 things. One is I'm aware of at least 1, probably up to 3 implementations of the Bow interface that aren't the open test chip. But I believe even the private implementations can benefit from a common test and validation infrastructure is the hunch I'm operating on. So really the idea with this combined test chip project is not just to develop the base test chips, but also develop the test and validation infrastructure on top of this. Right. So I think, DJ, we're ready to sort of release this document on a broader basis to anybody who wants it.
Absolutely. Yep.
Right. So we'd like you to, I'll reach out to individuals as well, but consider pushing this. Consider pushing this effort. I think we're beginning to get fairly decent. DJ, correct me if I'm wrong again, reasonable traction at the end users and reasonable unexpected positive development of the OCP. And so I think if we can get this third community leg worked out, we're in good shape at that point.
Exactly.
And if you notice, I've sort of put down two options in each level, kind of like a cash and kind contribution. So any questions? Any questions on this? So the general idea is that everybody here will circulate this internally in their organizations and sort of test the waters on interest in funding at either the gold, silver, or bronze levels.
One more thing, is there any company here help us to communicate the TSMC for a free shuttle for the test chip? I think we are going to look into that, but anyone else wants to help?
Actually, that's an excellent ask, Halil. Do you want to elaborate a little bit more so that people have context of what is it that you are asking?
But for example, whichever the company is going to do a test chip, like maybe it can be multiple. Like if we can talk to TSMC or the other companies who they can give us a free shuttle. Like sometimes they do that for a new idea, for a startup. Like maybe if the ODSA make it up or some companies has more saying, it can be very useful, you know. It's as good as the gold.
Yeah, so
Bitcoin
hey,
Halil,
can you guys hear me? This is Sid.
Sid, we can hear you.
Yeah. So hey, so you know, so I'll be happy to do that. I'm meeting. Just so happens I'm meeting TSMC this week. I'll be happy to bring that up. I will just try to set expectations. Lots of people have tried this with TSMC over the last couple of years with almost zero success, right? Especially, you know, given, you know, where they are as a company right now and their position. So I don't think we should pin our hopes on that. It's quite unlikely that they will agree, but it is certainly worth a try. It would help a lot more if one of the end users actually spent time with them to help them understand the importance of BOW in the ecosystem, because really that's the kind of stuff that, you know, makes them go, you know, gets them going, right? I mean, they really need to understand that there is, you know, multiple end users who are going to use this stuff. There's an ecosystem that's going to develop around it, and there could be lots of future business for them as a result of this, as a result of the success of BOW. And that is, you know, better. It's always better if it comes from a person who's actually going to use it, who's an end customer, who has clout in the industry, has a big voice in the industry. So that would be my recommendation. Having said that, I will be happy to bring it up this week when I speak with them, but I'm sure they will say, hey, you know, they'd like to hear from some of the end users.
So Sid, that's a fair point. Incidentally, we are already working on that angle. In fact, that's our primary way, but we are trying to build even broader momentum. So your point is well taken, and end user is already working in that direction.
Okay. Thank you.
I can add a couple of things, Dharmesh. Sid, two things we are trying to work. The first thing is get the TSMC advanced node access for the startups, whoever wants to do a BOW. At the same time, we will bring up the test free shuttle. And Ravi, our sourcing, is going to include the other end users to have a bigger voice instead of just only Facebook or something, like a bigger companies like who has lots of silicon there. We are trying to make a community there to gang them on.
Is there any interest in non-TSMC foundries? I'm asking, not commenting.
Before that, did we finalize the process node before talking to them? Do you want it in 7, 16, 5?
I think everybody, Shahab, everybody might have a different selection, like a 6 and 5 is the first one we are shooting to have the access. And if anybody comes up with a different node, we can bring that up, but 6 and 5 seems like front runners.
Yeah, I think 6 and 5 are the primary ones where sort of this effort would have very high impact. You know, if you go like even Moses has 12 available at this point. So there are ways of sort of getting to other nodes, kind of without necessarily requiring TSMC, although obviously they do require money. But yeah, I think 5 and 6 are kind of the ones that where getting this kind of effort going would have very high impact.
Got it. Thanks.
Okay, so where does that leave us when all is said and done? I mean, in my end, the ask, or our and DJ's in mind, the ask is to circulate the funding proposal within your companies. And anybody else have any, as far as the test chip goes, we're still, TSMC is the primary fab of choice, right?
Yeah, I mean, I think that's the place everyone's going to start.
Okay. Now, do we have any interest in other foundries or not? Again, I'm asking, not commenting.
I mean, I'm sure there is going to be interest in other foundries. Broadly, that's kind of a lot of what the whole chiplet thing is about, right? But I mean, I guess my suggestion only purely from the perspective of just sort of like doing a first thing well, right? TSMC is kind of the right answer.
Yeah, I would agree with that. I think we are trying to take our first step. It's probably best to start with TSMC.
Okay. All right, and then so that it does. I will send everybody access to this. Whoever's online, I have a. Let me just. Javi, I'm just going to paste the list of attendees over again. Oh, you did it. Good. All right, thanks. Let's see. So then the other. So then we've had this raging debate on the bump maps for the past 3 weeks. And I'm looking through the notes, and we never settled on a resolution other than it seems like both bump maps are possible, and we're looking at 2 test chips each with 2 different bump maps, right? Is that where we're ending up for sure?
Yeah, that was my understanding. Was basically, I think my understanding was that basically the quote unquote wider one would remain the thing that is sort of shown as an example in the spec, only because it sort of supports the single package layer types of designs. I think there was a little bit of question still on exactly which arrangement. So I think Javi had a slightly different arrangement than Ken had drawn. So there may be some small details there that can be decided. But I think from the test chip perspective, I think it was sort of a conscious decision was made to just let people try different things, and then if we see based on that data that indeed there's a strong reason to change or adjust or whatever it is, then we still have that flexibility down the road. At least that was my interpretation / understanding. So if anyone else thinks otherwise, please feel free to say so.
Okay, Sid Prasad, you're on the same page too?
Yes, I think that's my understanding, Prasad.
Yeah, that's my understanding too.
Okay, all right. So then if we're doing that, then I think the last topic, and I'll let everybody go early. As I said, one of the things that's happening in my mind is that we're going to have multiple bow chips, I think, if if everything goes according to plan, and since it always goes according to plan. So starting next week on, I would at least like to figure out the validation and test, and whether we can sort of create one common, so some sort of reusable collateral. One of the brightest spots right now is one of the good things that happened is our POC is working, and we had this plan of you building a validation board using the POC that we have, the board level POC. So fundamentally, if we're sort of on reasonable progress on the channel models and those are standing items, the other thing I'd like to devote time and energy to is to figure out how this thing works. If we make the test chip, how do we package it? How do they get tested? Do we want to test interoperability, et cetera, et cetera? That seems to be a good next agenda item. Does that seem reasonable or not so good?
That's definitely something we should figure out soon. So you got my vote.
Okay, thank you. Anybody else object or think it's a good idea?
I mean, I think my thoughts on that are interoperability is always a good thing, especially for what we are trying to do as a group. So any work we devote towards that is always going to be work, well spent.
Okay. So then what we'll do is starting next week, start trying to figure out the what happens. I think we know what we know about the test chip, and as we round up the funding, then we'll define the test chip in more detail, and we'll sort of shift our attention to the packaging of and the packaging and validation going forward. Does that sound reasonable? Shahab,
Sounds good to me.
Elad, and yeah, go ahead, Elad. I'm sorry, please.
Oh, I just said sounds good to me.
Okay. Then on that bright note, I think we're done, and unless somebody else has any other topics they'd like to cover. Oh, Satya sent me a whole bunch of things about channel models for the alternate bump map, but he's on vacation. He's away this week. Okay, maybe that's one thing we have to pick up next week. Okay.
So Bapi, I have one quick question.
Yes, Anu can commit to funding. Yeah, if that's your question.
Uh-huh.
Well, that question was for everyone, not just for Anu. So
No, that woke me up, Bapi. Thanks.
All right, that's going into the minutes.
So Bapi, we were talking about channel model. What I would like to do is capture a recommended channel model for the board test chip in the funding. There's a section for it, so that we all understand what kind of channel closure board test chip is expected to work against. And I think it would be good to capture board test chip related channel model. I'm not talking about all different types, but when we are trying to build a board test chip with 2 chiplets within a package, it would be good to also capture some details on what the channel structure looks like. Is that something somebody can help add into the document?
So it's partially in there at the moment. It's not the APD layout, but it's I guess the PowerPoint version of what it should look like. I'm not clear as to how you want to expand on that.
Okay, so Javi, thank you for chiming in. I know you actually added a portion there. What I would like to do is make sure everybody looks at it and see if there's anything else we need to add. So that's all my call out was for. If everybody thinks that that's captures everything, including folks who are trying to build the chip as well as packaging folks, if they have any questions, please comment on the document. Otherwise, yeah, thank you, Javi, for adding that section.
Okay. Halil, anything on your mind? Prasad? Shalab?
Not from me.
Nothing.
Halil?
I am good too, guys. Thank you very much.
Okay. Sandeep, Shalab?
Nothing, Bobby. Thanks.
Okay. Oh, never mind. Shahab said, okay, very close. All right. Okay. Well, in that case, everyone, yeah, you get 10 minutes of your life back before your next meeting. Thank you.
Thank you, everyone.
Thank you. Bye.